Okay, please log into Pear Deck. The code is on Google Classroom if you are not on it already. Okay, please take a minute and answer this warm-up. Make sure you get A through M. At least make a good attempt at it. Okay, we've been doing these for a few days now, so hopefully they're getting a little easier for all of us. Okay, so please pause the video and then resume it, and I will give you the answers. Okay, so hopefully you made a good attempt at the warm-up. Angle A should have been 112 degrees. We have a linear pair. Angle B should have been 68 because we have alternate interior angles. C then should have been 44 degrees because we have a straight line. D should have also been 44 because of alternate interior angles with C. E, we have a linear pair with D. So E was 136 degrees. And then we can find the top of our isosceles triangle, or a vertex angle. And since that is a vertical angle with D, we know that that is 44 degrees. And then F and G are our base angles, so they are the same. So F and G are both 68 degrees. K is also 68 because they are corresponding angles. F and K are corresponding. And then we can find H because F and the vertex angle of the next isosceles triangle is also 68 degrees. So H and this other angle, they are our base angles of our isosceles. Okay, so we take 180 minus this 68 and divide by 2. So H is 56 degrees. Okay, and then I like to find L next, because we have a straight line and we already found K and H. L ends up being 56 degrees. And since we knew this base angle of this isosceles was 56, we have a linear pair with M, and M ends up being 124. If you got about 4 of them wrong, make sure that you are understanding how you got them wrong, so for next time, or you're asking me questions. Okay, we're going to move on to our investigations for today. You will need your textbook, your pencil, your paper, your compass, and your straight edge. Okay, so please take a moment, pause the video to get these 5 things. Okay, so we're going to start with 4.4, okay, but 4.4 and 4.5, they are very similar, so that's why I put them together today. And we're going to talk about congruence shortcuts. Please take a moment and answer these couple questions. Okay, so what does it mean for 2 polygons to be congruent to one another? Do these sets of shapes appear to be congruent? And what information do you need to know in order to conclude that these shapes are congruent to one another? So there's a set of triangles and there's a set of, I think, quadrilaterals when you scroll down. So please pause the video, take a moment, answer this, please. Okay, so what I was looking for your answer is, we've talked about this a few times, is that in order for polygons to be congruent, all of their sides have to be the same. And all of their angles have to be the same. Okay, and we've talked about that before. And what we're going to get into today, if we don't know all of the sides or all of the angles in our triangles, there are some shortcuts we can use in order to determine whether they are congruent. So for example, if we only know like 2 sides and an angle, okay, could we determine that these 2 triangles are congruent to one another? If we only know a side, and an angle are congruent, could we say the entire shape is congruent or not? So we're going to have a few conjectures today. So make sure you also have your conjecture sheet out. The first investigation is the side, side, side. So if we know all 3 sides are congruent to one another, can we say that the entire triangles are then congruent. So you're going to construct ABC using these measurements in your book. And then you're going to compare with your other group members. Okay, so on the next slide, compare with your group members, and then did you all get the exact same triangle? Okay, or were there different triangles? So please pause the video and take a minute to complete investigation 1. So at this point you should have completed investigation number 1. So the side, side, side congruence conjecture is actually true. If the 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles have to be congruent. So that means all of their angles are also congruent to one another. Okay, so the side, side, side is kind of a congruency shortcut. Take a minute, write this on your conjecture sheet. As always, draw a picture like the one shown. So the second investigation, now we're talking about side, angle, side. So if we know that a side, an angle, and a side are congruent to one another, like this picture, then will the 2 triangles be congruent? Okay, and now notice it says if 2 sides and the included angle, so the angle has to be in between these congruent sides here. Okay, so for this example, notice side, angle, and side. So the angle is in between the congruent sides that we know. Okay, so will the triangles be congruent? Take a minute and then compare with your group members. Did you all get the exact same triangle, or did you get different triangles? So you should have found out that the side, angle, side conjecture is true. If we know 2 sides and that included angle, so the angle that's in between those congruent sides, are congruent, then the triangles must be congruent to one another. So then we know all of the sides will then be congruent and all the rest of the angles are congruent. So this was just a shortcut. Take a minute, write this down, and draw a picture, please. Investigation number 3 is the side-side angle congruence conjecture. Notice this time the angle is not in the middle of those 2 angles. This time it goes side, next to angle. Okay, so they're all 3. Notice it goes in the order of which the letters are in the congruent shortcut. So side, side, angle, side, side, angle. Please take a minute, complete investigation number 3, and compare with your group members. Did you all construct the exact same triangle, or did you have different triangles? Pause the video, complete investigation number 3. So you should have noticed that side-side angle is not a congruence conjecture. Okay, so it's not possible if you only know a side, and its angle. Okay, notice that the angle is not included, so that's different. It's different. Okay, and this picture proves why side-side angle cannot work. I have the exact same lengths, and I have the exact same angle, but notice I can extend this side out as far as I want, and this angle up at the top changes. Okay, also I like to remember it as, if you spell it backwards, an appropriate word. Okay, so it is not okay in real life, right? An appropriate word, and it's not okay in congruent shortcuts. So be thinking about that as well. Okay, so there are other congruent shortcuts, so we have a couple more investigations in 4.5. Please take a minute, construct this triangle MT, given this segment MT and angle MT, so angle, side, angle. Okay, if we know Angle, side, angle. Notice the side is included, so it's in the middle of the two angles for this one. Would the whole triangle be congruent? Again, compare with your group members. Okay, did you all get the same triangle, or did you come up with different triangles? Okay, if you came up with different triangles, then it does not work. If you came up with the same, then it works. Pause the video, complete investigation 1. So you should have found out that if we have two angles and the included side, we know those are congruent to another triangle, then the triangles have to be congruent. There's no other way you could draw that triangle. Please take a minute, write this one down, and make sure you always draw the picture. Okay, we have investigation number 2, which is side, angle, angle. Okay, so notice the side, angle, angle on here. Construct KLJ triangle. And again, compare with your group members. Okay, did you all get the same triangle, or did you get different triangles? Pause the video, complete investigation 3. You should have noticed that it is true if two angles and a non-included side, so that means the side is not inside the angles, are congruent, then the triangles are going to be congruent. Okay, so this is another congruent shortcut. Please take a minute and complete. Investigation number 3 is angle, angle, angle. Please use these 3 angles given to construct a triangle. Compare with your group members. Is it possible to construct other triangles with those 3 segments or measurements? Pause the video, complete investigation number 3. You should have found out that angle, angle, angle is not a congruence shortcut. This picture shows why. We could have a really tiny equilateral triangle, okay, or we could have a really, really big one, okay, but notice that does not work. Different sizes, different sides. They are not congruent. So angle, angle, angle is not a congruent shortcut. If you need to write that down in your notes, please do so. Here are a couple examples of what might these type of problems look like on a test or a homework assignment. Okay, so state if the two triangles are congruent and tell me what congruence conjecture, like side, angle, side, or side, 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 angle, side, angle, about it. Okay, so here notice that we have this side length is congruent to this side length. We also know that there's an angle congruency. And we have this same segment, right, because they're put together. They're right next to each other, so they share this. So this is obviously congruent as well. Okay, so we have a side, and an angle. And if we know side, side, angle, that was not a congruence conjecture. So these two triangles are not congruent. Number 2 here, notice that we have two angles and we have the side that is congruent, right? Because just like the previous one, they share that segment. So we have an angle, a side, and an angle. And we know angle, side, angle is a congruency shortcut. So now we can say these two triangles are congruent. This one, these two triangles are congruent because we have side, side, side. Please complete 1 through 10.